Okay, I know I said I'm retired, but this is a customer's, but he's a local good guy. I've been knowing him a while, and um, decided to go through his Blackcat JB-2000 1080 version, which is 10 through 80 meter version, no driver tube. A ham amp with 10 through 80 meters is basically going to be a 100-watt drive or more per FCC. And this one had all the ham bands in it, and the customer wanted it monobanded. Actually, it was already monobanded. It was just a strap to bypass all the ham band stuff here. For 10 meters, I always say you need about 4 turns. And from the factory, this is the factory coil, or at least most of it. It's about 4.5 turns from the one side, input side, to the output side, which was tapped right here. That was 10 meters. And then it went through this switch here when it had all the bands in it. And, on 10 meters, it was tapped here, and then that went to the output side of the coil. One side goes to the tune cap, the output side goes to the load cap. And on 10 meters, you just use those 4.5 turns. For 15 meters, you use these 2 other extra turns, which you would take this tap off and then tap to the other end of that, which would give you 15 meters. And that would be there, and from there it'd be 20 to that tap using the switch. It would be 40, and then down at the bottom, using all the coils all the way across, it would be 80 meters. And at some time, I don't know whether it was 40, 80, or what, the little load capacitor in these amps, that little guy at the bottom there, could not didn't have enough capacitance for the lower bands, so it would switch in this cap here for maybe 40 and 80 meters, maybe just 80, maybe 20, 40, 80. I didn't even really look at it, but anyway, monoband 10, 11 meters, or 10 through 12 meters, basically 4 turns. This one's 4.5 turns from here to here. That's where the original tap was, and that's what we're gonna eventually stick back in here after we clean it up and resolder it and check on our path. This here's the top side, of the tubes. The plate of the tube is the plate voltage, or the high voltage side, and this is unplugged, hadn't been plugged in, drained, all that stuff, so don't do that at home. This is the danger side, the high voltage side, or I was going to say the kill zone side here that I'm touching with my fingers. Like, don't do that. This side with the plate is going to be the high voltage, and it's marked there about 3,000 volts. I think the Blackcats actually run about 2,700. I think the ones with the driver tube ran with about 2,200, and they use half of it in a doubler circuit, and they used the 1/2 to run the driver tube. They ran about 1,100 volts on the driver tube, a tube that's actually made for about 600-700 at most, and of course they kill that driver tube pretty quick in the ones with a driver tube. It just was not a good design, and I won't even do one with a driver tube anymore. Just from factory, not a good design at all. But anyway, with the kill zone, the plate got the high voltage going to the tubes coming out the tubes, you know, through the kill zone. You get the high voltage and the RF coming out. Go through this parasitic choke, which stops, or, you know, tries to stop parasitic oscillations. Parasitics are, you know, attenuated, you know, by this choke. That's the design of that. You don't need a lot of that for 10 meters or 11 meters. But for the ham bands, you absolutely need it. This choke here, the RF choke, or the blocking choke, the DC, the 3000 volts, comes into the bottom of that and goes up to the top and then to the tubes. But RF does not like going through a choke. It's like an open circuit for RF. So RF won't go back down the choke. It's like a one-way valve for DC can come in, but RF can't go out. So it's an open circuit for RF. So the DC comes in, RF can't go out, and the RF and the DC mix in the tubes. And then the RF and DC comes to this side of the cap. And this cap works like the reverse of this choke here. This cap, you know, small value, RF is fast, so this small value cap will let the fast RF, you know, go through, you know, real fast. Bop, 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 bop. Can't believe I said that. It's late, I'm sleepy, so forgive me. But anyway, the RF can go through here, but DC can't go through a small cap, you know. So the DC is blocked here. So open circuit for DC, and like a dead short for RF going through this small value cap, where the choke is the opposite. It's like a dead short for DC. You know, DC likes to go through wires. You know, don't care what the wires are. DC will go right through it. But RF does not, you know, because it's trying to go fast and it's just blocked by, you know, that choke there. So anyway, the RF, you know, is going to be on this side of the cap, and the DC is stuck over here. So you got your output RF only. One thing, if this fails, and they do, you will get your RF on this side, and that'd be catastrophic. You know, you got 3000 volts DC now, you know, going out through your coax and your tune caps and everything else where it's not supposed to be, and that could kill somebody. So what they do is, that blue choke there is another RF choke, but this one's connected to ground. So RF, again, doesn't like going through this coil here, so it's an open circuit to RF. But if this fails and the DC starts coming in, because that shorts out, you know, too much drive, or this old and tired, that shorts out, the RF goes through there, it's going to be grounded. Remember, DC likes to go through wires, and that's all this is. It's another choke, or, you know, wires. And the DC will be grounded out by this, so that'll stop the DC, which will kill you, or, you know, do some real damage. You got 3000 volts going through your system, your radio station, and all that. It'll kill everything, your radios and probably anything else in line, right? So that's a safety choke to block that DC if that happens to short. Amp will work fine without this, and if this never shorts, you know, hey, no problem. You know, it's a safety device, kind of like a fuse. You can bypass a fuse if you want to. You know, some people do it at their homes, you know, bypass the circuit breakers at home. But, you know, if something happens, oh boy, cancel Christmas. So anyway, the RF comes in, you know, this side, the DC blocked over here. It goes to the tune cap, and the tune cap basically tunes in your tubes. On the CB version of the JB-2000, they often use the fixed tune capacitor. Because if you got a, you know, a pair of EMAC 3500Zs, and you know you need exactly 67 picofarads of capacitance to tune in your pair of 3500Zs, you can get rid of this tunable cap and put in a fixed cap that'll handle, you know, all that RF. Some fixed caps. And on the early JB-2000s, the CB versions, they did just that. You didn't need the ham bands and you know, tune this into all the different ham bands and all that anyway. So they used a fixed cap. Even on the JB-12s, JB-76s often, there's no tune on them, and a lot of them don't have a tune in the load either. So they're just fixed. They're not adjustable or variable. But the load down there, that smaller one, it doesn't have to handle as much voltage as the tune does. That's why you always see the tune is widely spaced. Normal amp building, you want the tune cap to handle double the voltage of the your high voltage. So if your high voltage is 3000, you want this cap to handle 6000, but a lot of times they chintz on that too, you know, again, cost, right? And then your load cap, it can be about 1/4 the voltage of your 3000 volts. And what's 3000 divided by you know, 0.25, what, about 650, 750, something like that. 750, I think. Like I say, it's late, my math isn't working today. So anyway, that needs to handle only 750 volts. So that's why the spacing can be that much closer. And the load cap basically tunes your antenna. And since antennas vary, you know, it might, one antenna might have more capacitance and less inductance, and vice versa, even though they're, you know, 50 ohms, and some of them be off, or, you know, not tuned perfectly like a dummy load. So basically, you'll always see it, almost any amp they have a load, because that tunes your antenna. It's hard to put a fixed one on that because you don't know exactly what your load or the output side of that is. But often you will see on CB amps that they use a fixed tune cap. But anyway, this is the danger zone. Keep your hands out. Don't go in there. Or the kill zone. That's the word I wanted to use. Kill zone right there. You know, 3000 volts, everything exposed here. And, you know, that fails. You're going to get it all through here too. Some CB amps don't have that safety choke right there. So if that does fail, oh boy, cancel Christmas. You might be done, you know, on a bigger amp. And again, monobanded, that 4 turns, it's gonna go in there somewhere, you know, like that, nice and neat, you know, once I figure out how I want to do it. I think it was installed this way originally, and then the holes there. Nope, not a driver tube. This was the ham amp again. That was where that ham band coils were. But again, 10 meters, 11 meters, 12 meters, basically 4 turns. Power transformer, voltage doubler, which ain't the best as far as you know, current capacity and holding the load, but again, cost thing. And then with the Blackcats, they also have the filament transformer and all in the one transformer. A lot of the better amps, they use a second filament transformer, so that doesn't, you know, the main transformer doesn't have to handle everything. It does have a meter with I think voltage, RF, and current on it, switchable. Uses a fan, not even that great a fan, but again, this is 50 years old. Modern box fan to blow more air. And a better amp would use a blower and chimneys and get some air on the sockets. But at least they got the sockets, you know, designed so they can get some airflow going through on the sockets. 3500Zs, a lot of times, you know, they run 5 volts at 15 amps a piece, and a lot of times the connections on the sockets get hot with all the heat, and it burns up the socket connection on the tube or on the socket itself. So anyway, that's a run through of this 3500Z Blackcat JB-2000 top. I've done more before, but since it's on the bench and we're monobanded it, we decided to go through it. We'll probably do a one on the bottom, especially the electrolytic capacitor bank, coming soon. A lot of people asking about that. All right, that's it for this one. Bye.